at target 1D.1, I can solve an equation using rational exponents. Our 1D.1 mastery learning objective says I can solve equations by applying the rules of equality to isolate the variable. So what does it mean to solve an equation? Okay. Really, we want to, what this phrase is, isolate the variable. And what does that mean? Isolating the variable means the variable is alone on one side of the equation. Okay, so you want to get that variable alone. Once the variable is alone, you've solved for that variable. However, if the variable is not alone, you aren't done yet. Okay. All right, so how do we get this variable alone? We do inverse operations. And inverse operations are just opposites. And then because they're opposites, they cancel each other out. So thinking about what some of our inverse operations, the basic ones you know, right? Addition and subtraction are opposites, right? Multiplication and division are opposites. And then the one we just did in target C, taking the square root of something and squaring something are opposites. So these are some of our inverse operations we can use to get our variable by itself. All right, step 1, locate the variable. Step 2, use your inverse operations on both sides of the equation. We follow the opposite order of operations. So in order of operations, usually addition and subtraction are last, but in solving, they're first. Okay, so that's a very important thing to keep in mind. Then we simplify and repeat. Locate the variable, use your inverse operations, blah, 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 as many times as necessary until that variable is by itself. Okay? All right, the first examples we're going to look at are one-step equations. These are equations that have one step to them. All right, so again, our first thing to do is locate the variable. Okay. I like to draw a line through my equal sign so I can tell what side is the left side and the right side of my equation. So right now x and 13 are on the left side. I need to get rid of that 13. Since it's being added, I'm going to do the opposite and subtract 13. And then anything I do to one side, I have to do to the other side of the equation. They cancel, and I'm left with x equals, and 19 minus 13 is 6. Done. Easy enough. Looking at number 2, right? I'm going to, again, draw that line. 46 equals y minus 20. Here's my variable. Y is on the right side of the equation. So is this minus 20. So this, I have to get rid of that. So I'm going to add 20 because addition is the opposite of subtraction. 46 minus, add 20. 46 plus 20 is 66. Bring down the y, those cancel. 66 equals y. Done. Looking at example 3, 22 equals f divided by 6. Here is my variable. I have f divided by 6. Right? Anytime you see that fraction bar, it's division. We've seen it on fraction a lot, but just keep that in mind. It's still just division. And the opposite of division is multiplication. So I'm going to multiply by 6. It's just a weird standard notation rule that for multiplication, we multiply on the side more often than multiplying on the bottom. And because like multiplication gets distributed or random things. So it's pretty standard to write it on the side like I did, instead of on the bottom like I did with addition and subtraction. Okay. So then 6 times 22 is 132. Again, feel free to use a calculator, but for the sake of time, you can trust me on that one. And then f divided by 6 times 6, those cancel out. Right? So I'm left with that f. F is now alone on the right side, so f is 132. Done. Example 4. Again, I'm going to draw my line. There's my variable k. It has this 3. If there's nothing, it is a multiplication problem. When they're just written next to each other, they are being multiplied. Okay, so multiplication is the only one we don't have to write. The only operation we don't have to write. So this is 3 times k. The opposite of multiplication is division. Okay, and again, we want to get away from using that symbol. We don't like it. Just a fraction bar from pretty much here on out will represent division. My 3's cancel. I'm left with k equals 126 divided by 3 is 42. Again, feel free to use a calculator, but again, for sake of time in our video, you can trust me. All right, let's go to the next page and look at some examples here. These are now multi-step equations, so I'm going to do more than one operation. So I have 10x plus 33 equals 3. Here's my variable. Right now I have 10 and that 3 on the left side of the equal sign with the x. So now we have to think about which one we want to get rid of first. But again, going back to what I said earlier, it's the opposite of order of operations. So it's always addition or subtraction first. Okay, so we have this plus 3. So I'm going to minus 3. They cancel, so I'm left with 10x. 33 minus 3 is 30. Now again, I'm going to locate my x. It still has that 10 with it that's being multiplied. So I'm going to divide by 10. Cancel. And 30 divided by 10 is 3. Moving right along to example 6, 5x minus 8 equals 32. I'm going to draw that line. Okay, there's my x. Again, addition or subtraction first, so this has a minus 8. So that means I want to add 8 first. Cancel. I have 5x equals 32 plus 8 is 40. Finding my x, right? It still has that 5 with it being multiplied. So I'm going to divide x equals, and 40 divided by 5 is 8. Okay. I'll do one other quick example, because these pop up sometimes. If I have something like 5/3 x equals 12. Sorry, I'm trying to think of a good number. Okay. My x is here. You can think of your fraction as 2 operations happening, right? It is being divided by this 3. So I'm going to multiply by 3. And they cancel. Right? So then I'm left with 5x equals, this was not a good problem. That's okay. Not a good number. 36. Now my x is here. It's still being multiplied by that 5. When I divide 36 by 5, you just get 36/5. Okay, so if you get a fraction, it's okay. I promise. Okay, so when you have that fraction in front of x, you can think of it as a division and then a multiplication. Okay, so you're just doing the opposites of those. All right, let's look at our last set of examples if we have variables on both sides. All right, so if I look here at example 7, move up. I have 3x plus 20 equals 2x minus 8. And if I look for my variable, I have an x here and an x here. I can't isolate the variable to on one side if it's on two sides. So we always want to get rid, get rid of one of the variables. It doesn't really matter which one you get rid of. I usually get rid of the one on the right side. I tend to just like variables on the left side. But mathematically, it doesn't matter. Okay, so I'm going to get rid of this 2x. I get rid of the 2x by subtracting 2x. Okay, so whatever coefficient is in front of the variable has to go with it. It can't just be like the x. It has to be the 2x. So 3x minus 2x is just 1x. I don't have to write the 1 in front. All right, so now I have x plus 20 equals negative 8. There's my x. All right, so it has a plus 20, so I'm going to subtract 20. Those cancel. Negative 8 minus 20 is negative 28. Nice and easy there. Okay, so just getting rid of one of them is easy enough. Same thing here. I have a negative 7x and a negative x, or a minus x. So if I want to get rid of the one on the right, I'm going to get rid of this minus x. The opposite of subtracting x is adding x. So now my x is just here. So now I have to get rid of this, right, addition or subtraction first, so the plus 11. So I'm going to do minus 11. So I'm left with negative 6x. 19 minus 11 is 8. Here's my x. It's being multiplied, so I'm going to divide by negative 6. And then if you do 8 divided by negative 6 in your calculator, you do get negative 4/3. And again, fractions are okay. Don't be too afraid of fractions. All right, that's it. Go ahead, work on your D1 activity.